Hello everyone, welcome back. So in this video we are going to learn about the fourth type of flip-flop, which is T flip-flop. Okay, so T flip-flop. If you are first time to my channel, please consider subscribing. So T flip-flop, the full name is, or the name of T flip-flop is toggle flip-flop. Okay, so toggling. So what do you mean by toggling is changing the output from 0 to 1. So if the present state, that is Qn, is 0, then Qn plus 1 must become 1. So that is called as toggling, or changing from 1 to 0. If Qn is 1, then Qn plus 1 is equal to 0. So this condition is called as toggling. That means 0 is changed to 1 or 1 is changed to 0. So that condition is called as toggling. So T flip-flop is a toggle flip-flop. Okay, again the important point or the characteristic definition of T flip-flop is T flip-flop is again obtained from JK flip-flop. Okay, so T flip-flop is obtained from JK flip-flop. So T flip-flop obtained from JK flip-flop by connecting J and K inputs together. That's all. So if you remember this, then everything will become easy. So T flip-flop is derived from JK flip-flop by connecting J and K inputs together. Okay, so if you remember this point, then it is easy. So again I am drawing JK flip-flop, JK, because T flip-flop is a derived flip-flop. It is not a new flip-flop. It is again derived from JK flip-flop only. Okay, so this is clock pulse Q bar. So JK flip or T flip-flop is obtained by connecting J and K inputs together. That means T is given to J and T is also given to K. So J is equal to K is equal to T. Okay, so using this condition, now we'll see the truth table. Truth table of T flip-flop. So T Qn plus 1. So T, since there is only one input, there are only two possibilities: T is equal to 0 or T is equal to 1. So when T is equal to 0, then J is equal to K is equal to 0. So when J is equal to 0 and K is equal to 0, then what is Qn plus 1? Qn plus 1 is equal to Qn. So this is what we have obtained in JK flip-flop. So Qn plus 1 is equal to Qn. Similarly, when T is equal to 1, then J is equal to K is equal to 1. When J is equal to 1 and K is equal to 1, then what is Qn plus 1? Qn plus 1 is equal to Qn bar. So this is Qn bar. Okay, so this becomes the truth table of T flip-flop. So once you obtain truth table, we can obtain excitation table. Okay, so excitation table. So excitation table Qn plus 1 T. So 0 0 0 1 1 0 and 1 1 4. Because there are two inputs, so we'll have 4 combinations. Now see the first combination, Qn plus 1 is equal to Qn, yes or no? So Qn plus 1 is when Qn plus 1 is equal to Qn, what is the value of T? 0. When Qn plus 1 is, so in the second case, Qn plus 1 is equal to Qn bar. So when Qn plus 1 is equal to Qn bar, then what is the value of T? 1. And in the third case also, Qn plus 1 is equal to Qn bar. So when Qn plus 1 is equal to Qn bar, then what is the value of T? T is always equal to 1. When there is toggling, that is 0 is changed to 1 or 1 is changed to 0, so T is equal to 1. So that is why this is called as toggling, and the flip-flop is called as toggle flip-flop. So Qn plus 1 is equal to Qn. So in the fourth case, Qn plus 1 is equal to Qn. So T value is equal to 0. Okay, so very simple. So this is how we are obtained the excitation table. So the last is characteristic table. In order to obtain characteristic equation. So characteristic table first. So Qn plus 1 is function of T and Qn now. Since toggle flip-flop or T flip-flop will have only one input, so Qn plus 1 is function of T and Qn. So T, Qn, Qn plus 1, 0 0 0 1 1 0 1 1. So when T is equal to 0, what is Qn plus 1? Qn plus 1 is equal to Qn. So for the first two cases, T is equal to 0, so Qn plus 1 is equal to Qn. So it is 0 and 1. And for T is equal to 1, the second two cases, T is equal to 1. So since T is equal to 1, what is Qn plus 1? Qn plus 1 is equal to Qn bar. So since it is 0, we will write 1 here, and since this is 1, so we'll write a 0 over here. Okay, so if you observe, this is the XOR gate operation. 0 1 1 0 is XOR gate operation. So if you have A, B, Y, so 0 0 0 1 1 0 1 1, so we'll write 0 1 1 0. So Y is equal to A XOR with B. So this is same. So we can write the characteristic equation as Qn plus 1 is equal to T XOR with Qn. So T and XOR with Qn. So this is the characteristic equation of T flip-flop. Okay, so this is about T flip-flop.